Hello everyone and welcome. Today I would like to talk about multiply strings. Multiply strings. This question provides you two non-negative integers num1 and num2 represented as strings. For example, 1, 2, 3, 4, 5, 6, and asks you to return the product of num1 and num2 also represented as string. For example, 56088. You may be thinking, it's easy. I just convert the string to integer, multiply them together, and convert them back to string. Well, if it's that easy, it wouldn't be a median level question, would it? In fact, the question tells you must not use any built-in big integer library or convert the input to integer directly. So no conversion of the input to the integer directly. Some of you may be thinking, well, let's not use the integer function. Let's use our customized function string to number. And we do convert the string to number in a more elaborate way. Is it okay? Unfortunately, the answer is no. No conversion of the inputs to integer directly. This is definitely not what the question is looking for. What the question is looking for instead is your software steps to track the numbers and their digits and their places using pointers, as well as your software steps to use mathematical operation of multiplication and sum up all the intermediate steps together and generate it as a string. So let's get to that shortly. Now, I would like to offer 4 tips for this question. You may pause this video to read the information in some details. Number 1. The product of an m-digit num1 and an n-digit num2 has up to m plus n digits. Think of 99 times 99. Both have 2 digits, so the answer has up to 2 plus 2, 4 digits. So we can pre-populate the answer with m plus n zeros and then add or update the number into this pre-populated answer more easily. Number 2, to use an ascending for loop, like from low to high, to process the digits from lower to higher places, store the num in a reverse order array. So for example, this 764. The 7 is in the hundreds place, 6 in the tens place, 4 in the ones place. If we store this number in a reverse order array like 4, 6, 7, and we track those places or the digits using a pointer, let's say j, then when j is 0, 1, 2, like from low to high, ascending order, we can track the digits from the lower place to higher place a lot more intuitively. Number 3, how do we track where the right place it is to add to the answer? Observation. When we multiply a digit in the tens place by another digit in the hundreds place, the product will add to the answer in the thousands place, like this 9, 7, and the 3. In general, when we multiply a digit in the i's place by another digit in the j's place, the product will add to the answer in the I plus j's place. Number 4, and this is specific to Python, the ordinal function ORD and the character function CHR may be used to convert a Unicode character to an integer and an integer to a Unicode character. And so we can avoid using the int function, but we can still do the conversion this way. With all the background introduced, now let's get to the exciting part, the code writing. So first of all, we reverse the two string order in order. So we're doing slicing in Python. And the purpose of doing that, is to make it easier to track the low to high place in number using low to high pointers in array. So, for example, we track instead of 1 to 3, now we track 3 to 1, and the low pointer will be 0, point to a lower place here. So, and then we'll take their length. So using a length function, and num1 and num2 currently is reverse strings, and we populate our result with m plus n zeros. So we populate the result with m plus n zeros. Then we do 2 for loop for the 2 numbers respectively. And so for the first number, we have the first digit equal to num1 I, which is a character here, and we want to convert it to digit. So we use the ordinal function to convert this character to digit, and minus 48. And d2 similarly, num2j minus 48. And then we want to track if we have a product of these 2 digits, where should we insert or should we add to the results array? So it will be I plus j. And now what's our product? We'll simply d1 times d2 and any carrying from the previous operation. So any carrying from at this place. So this is important. We are able to keep track of the carry over calculation from the previous calculations. And then we have this P product. Now we add or and update the result. So first of all, we update this place using P divided by 10 and the remainder part, the single digit part. So it just updates since it add the previous one and it plus d1 times d2 and it update into this place again. And then for any carrying part, we add it to the next p index plus 1, the next place. So will be a 4 division, the 10th digit part, the 1st digit part. Okay, so this is all it takes to calculate the results array, the modification. And so we'll now want to return the result, but before we do that, we want to remove any leading zero. So okay, so let's see if we one space here. We want to pop any leading zero. So it's to trim any leading zeros. And remember, this is a reverse array, so the leading zero is at the very end. And finally, we'll return the result. So we reverse this array, and then for each digit in this array, we want to convert that digit back to character. So d plus 48 and the carry function will give us the character. So like 0 will give it a character 0. and then simply join this part, or we kind of concatenate all these characters one by one together, and then we return it. So that's it. That's our multiplication code of two strings, and let's test how it works. So submit, and done. With 92 milliseconds, it's pretty good. Now, let's analyze the code for complexity. And before we do that, just want to mention some of the comments we can improve for more accuracy. So this is not the ones digit, actually it's the I plus J's place part. And the thing here is the I plus J plus 1's place part. And also want to mention for this P index I here, it wouldn't exceed the results range because I and J were indexed from the zeros. So think of the most you can get is n minus 1 and n minus 1. So m plus n minus 2. And if you have that plus 1, it will be m plus n minus 1. So it's exactly the last element in that results array. Okay. And for time complexity, since we have this double for loop, and it has m element here, and the other for loop has n element here, so the time complexity will be om times n. And for space complexity, since we have this m plus n number of element in this results array, so that will be om plus n here for the space complexity. And that's it. That's all for this question. Medium level question. Take a lot of this software planning and consideration ahead of time. So hope you find this video to be useful, and please subscribe and stay tuned for more videos. Hope to see you next time. Goodbye.